Today we are looking at De-mogans law. As you have seen, just as it is written here, we need to prove De-mogans law. Right. So here what we are going to do is we are given this set, this law, that is De-mogans law. We need to prove that this is equal to this and also this one is equal to this one. Right? So solution. As you write solution, I have written proof because we need to give a proof that this is equal to this and this is also equal to this one. So when you write proof, you need to make this statement. We need to prove that, or you can say we need to show that this is a super subset of this and this is also a super subset of that one. Right. So we begin and say let X be a member of A intersection B complement. Alright. Then you are going to know that X is not going to be a member of A intersection B. Why? It is only a member of A intersection B complement. Alright? Yes. So that is what you're supposed to know. Then if X is not a member of A intersection B, of which set could X be not a member again? So look at this. We need to change this intersection to union. Alright? So we need to come up with something that is looking like this. So if X is not a member of all these things, let us consider that we are going also to say X is still not a member of A, or X is also not a member of B. You've seen it? If X is a member of A intersection B complement outside the bracket, it means X cannot be a member of A intersection B, or X cannot be a member of A, or X cannot be a member of B. Now, which set does X belong? Alright, so let's look at this. So X, so here we're going to say not a member because it's not a member, right? Yeah, so not a member. Okay, so X is now going to be a member of A complement. X is going to be a member of A complement, or X is going to be a member of B complement. Also here it's like that, right? Yeah. So if we have seen here, we are almost approaching to this answer. Right? We are almost approaching this answer. Remember, this is the left hand side, right? So we can say left hand side. Right? So this is the left hand side. Okay. Yes. So now if you have seen that you are almost approaching to this answer, what you need here is you write, because this intersection, you need to come up with a union, not intersection. So for you to come up with a union, you don't need to go direct. You need to make a word that is suitable here. So to change an intersection to union, we use a word or. For you to change a union to intersection, we use and. Right? Yes. Okay. So this is what we are going to write here. So we're going to say X is a member of A complement union B complement, like that, right? Then we can now conclude and say, therefore, A intersection B complement is a super subset of A union B, like this, right? Everything complemented. So this means we have proved the left hand side. So now we need also to prove this the right hand side, that it is equal to the left hand side. Okay, so we are going to write here right hand side. Okay, so for the right hand side, we are going to say let Y be a member of A complement union B complement. Right? Yes. So if you've noticed, whatever we have written here from the top to bottom. It is also the answer for this one. So all you need from this part is to start from the bottom going upward. If you can manage to copy everything from here up to here, then you are good to go. Alright? You are good to go, because you are going to notice that what we have started with here is what is the last part on this side. Right? So let's proceed. So we're going to say let y be a member of A complement union B complement. Alright? So you're going to notice that y is going to be a member of A complement, and y is also going to be a member of B complement. Alright? Yes. So now what we need here is to understand nicely, right? Okay, let's proceed. So we are going to say y is not a member of A, and y is not a member of B, because it is a member of A complement and is a member of B complement. But we need to come up with something that looks like this, right? So we are going to say y is also not a member. Since we have already come up with and, we are going to say y is a member of A intersection B complement. Alright. Since y is a member of A complement union B, and is also a member of A complement, and y is a member of B complement, then we are going to say y is not a member of A and y is not a member of B, but of something that is complemented, something that is removed. Alright, so now we are going to say y is a member of A intersection B complement. Then this concludes to say, therefore, A complement union B complement is a super subset of what? Of A intersection B complement. Alright, then now at the end, like this, yes, we have proved, but we need to make a statement at the end. We are going to say from the left hand side and the right hand side, we can see that A intersection B complement is equal to A union B complement like that. So this marks the end of proving De-Morgan's law. Goodbye.